Question 4. Some friends eat lunch regularly at a cafe. They aim to meet at 1300. Sarah walks 60% of the time and alternatively takes the bus. Walking, they are late 5% of the time. By bus, they are late 65% of the time. Label each branch of the tree diagram with the appropriate probabilities. So we can see here we have a choice of walk or bus, and then if you walk we have a choice of on time or late, and the bus on time or late, and we have 1, 2, 3, 4 different pathways set out. It says about 60% of the time walking, so we know that it would be 40%, 0.4, to be taking the bus. It then says walking they are late 5% of the time, which means late 5%, we're going to put that down as a decimal, 0.05, which means 95% on time, 0.95. By bus, they are late 65% of the time, so we have 65 there, and it was already filled in for the 0.35, 35% on time. So just to think it through, we have 1, 2, 3, 4 pathways. Part B. Calculate the probability that on a random day they will have taken the bus and be late. Taken the bus and be late is that pathway there, pathway number 4. So I'm going to write down its pathway number 4. How do we work it out? 0.4 multiplied by 0.65. So we have 0.4 multiplied by 0.65, 0.26. What's the probability they will be late? Late is here and here, so we've got two pathways. It's number 2 added on to the possibilities of pathway number 4. So it's going to be 0.6 times 0.05, multiplying on the tree diagram as we always do, plus the answer that we just had, which was 0.26, 0.6 multiplied by 0.05, and we get 0.03. That is 0.03, so we have 0.29 as our final answer. What's the probability that they will have walked given that they were late? So if we know they were late, the pathway pathway at the top, number 1, and then pathway number 3, these two aren't possible. Our denominator with this conditional probability, it's going to be out of 2 and 4. Which one of those is for walking? It's pathway 2. So this is the fraction that we need to find. We have the values from just above. That's 0.03, that's 0.29. So we just need to do 0.03 divided by 0.29, and we get 0.103 as our probability. Alex either cycles 20% of the time, they are late a quarter of the time that they cycle, or runs, so it's cycle or runs. If they run, they are late 10% of those days. So we're going to create our own tree diagram here. So it's cycle, run, and then we have on time, late, on time, late. What are the probabilities? So cycles 20% of the time, so that's 20% leaving 80%. They are late a quarter of the time they cycle, so they are late a quarter, 25%, which means 75%, 0.75 for on time. If they run, they are late 10%, so they are late 10%, which would leave 90% on time, and that is pathway 1, 2, 3, and 4. That's the tree diagram. Part 2, calculate the probability that on a random day, Alex will be late. So that is pathway 2 and 4. So that's going to be 0.2 times 0.25. And then pathway 4 is 0.8 times 0.1, 0.2 times 0.25, 0.05 plus 0.8 times 0.1, 0.08, we have 0.13. D1. Which of these two friends are on time more often? So we have Alex late in 0.13. Up above, Sarah late. Sarah late was the 0.29, 0.29. So that's late. So Sarah is late more often, which means Alex is on time more often, with the opposite of, or the complement of 0.13, it will be 0.87 that Alex is on time. D2, they meet 3 times a week, every week for a year. On how many occasions was Sarah late? So if Sarah is late 29% of the time, 29% of the time, and is 29% of the occasions, and we have 3 times a week times by 52, so if we do 3 times 52, they should have met up 156 times, so she is late 29% of the 156, so we're going to do 0.29 times 156, 0.29 times our 156, and we get 45.24, and therefore we will say that is 45 times to the nearest whole number.